let's do some review with monomials. And Kyra, if you just leave them on that desk, I'll just pick them up. Monomials. If I give you these two monomials and I tell you to add them together, what would you guess? That's Spenton? 9x. 4x plus 9x. Well, 4x plus 5x equals 9x, right? Can somebody tell me why I'm allowed to do that? Give me maybe the most basic thing. Why? Yeah, these two terms are like, so I can combine them together by adding the 4 and the 5. Okay, this is something I haven't done a good job of really emphasizing, but there's a property being used here. Does anyone know that property? To combine these two together, we're using this property, and what would it be? Josh? Distributive? Okay, how about this? It is a distributive property, but some of you are thinking, what? Is there a common factor between these two? Is there a common factor I can factor out technically? It's an x. What would be left in the parentheses? 4 plus 5. Can I add these two together? Mm-hmm. And I get 9 times x, which is 9x. Yes, it's factoring instead of multiplying. This is multiplying if I did that. This is factoring. Mm-hmm. So factoring pops up again. In fact, you factored many times before. You just didn't know it. Okay, we're good with this. What properties use to combine like terms? Distributive. Okay, good. Are you guys here? What properties use to add like terms? Distributive. And you guys understand that you could just add the coefficients? Great.
What if it's like 2 just numbers?
Oof. You stole my notes. What do you mean by numbers?
Like 2 just like 4 plus 5.
You're just adding the numbers, or they're like, technically, do they have variables? To what power? To the 0. So you can add those two together and just drop off that x to 0. So yeah, you can think of it that way, which is kind of cool. Thank you for asking. But I have another question. Can we apply like terms and adding of like terms to radical expressions such as 4 times the square root of 5 plus 5 times the square root of 5? And what's your guess on this one? What do you think it might be, could be, possibly be? 9 times the square root of 5. Okay. Maybe. But I thought you can add like terms. Are these really like terms? Okay, can somebody give me the definition of like terms? I want a definition here. There are terms that have the same with the same. Benson. Terms that have the same. Taylor?
The same variable with the same x.
Okay, so look back here. Do we have the same variable in these terms? Yes. Do they have the same exponents? Of course. Add them up like they are. But these don't have variables. Okay, I'm not going to expand on this more. But here, guys, I see not square root symbols. I see exponents that are fractions. Okay, let me rephrase that. Do you know that some exponents can be fractions?
Yeah.
Exponents can be decimals. And dare I say it, exponents can be variables. Okay, it can be imaginary, but that's technical stuff. So here, guys, they have like terms because I can really think of this as something which I will not expound upon. But if you didn't get that, does anyone know what factors out of these two? Is there a common factor? Square root of 5, good. And what would be left in the parentheses? It's the same principle. What property can I use to add radicals? Distributive. Yeah, sorry, distributive property. And then, yeah, you're undoing the multiplication that's going on there. Okay, do you guys see that? You have to know how to do this. And then this is the understanding behind it. Okay, let's go to our problems then. Let's see how these actually work out. Example number 1. 1A. Example 1A. And here's what they give us. 6 times the square root of 7 plus 5 times the square root of 7 minus 3 times the square root of 7. Uh-oh. How many terms are up here? 3. 1, 2, and 3. Okay, are these like terms? Yes. So if, and this is again how the understanding comes behind it, all three of these have the square root of 7. And if I factored that out, I'd be left with 6 plus 5 minus 3. So what would be my final expression here? 8 times the square root of 7 would be my final expression. So can I ask you here, these three terms can be combined into one term that has the same value because of like terms, or because of what property? Distributive. Good. So you don't have to use the distributive, like you don't have to show that, but it's there. So I want you guys to know that. Okay, B. Oh, B. Let me make it a little bit tougher on me. 5 times the square root of 6 plus 3 times the square root of 7 plus 4 times the square root of 7 minus 2 times the square root of 6. All right, I want to make sure I wrote that correctly. Maybe. Yes, okay. How many terms are up there, Beth? 4. 1, 2, 3, 4. Walker, what terms are like? Give me a pair of terms that are like.
First and last.
Okay, so the 5 times the square root of 6 and the negative 2 times the square root of 6. And those two combined, James, to give me what?
3 times the square root of 6.
3 times the square root of 6. Excellent. I need another pair if possible. Kendall, are there any other like terms up here?
Yes.
And what are they?
3 times square root of 7, and then 4 times square root of 7.
Good. And what do these two combine to give me, Eli?
7
So 3 times the square root of 6 plus 7 times the square root of 7. Can these two combine here? No. Because they are not like terms. They don't have a common factor other than 1. Okay, Benson, go ahead.
If the numbers on the outside are being multiplied by the number inside the square, why don't you multiply the numbers on the outside when instead you're adding them together, so why don't you multiply?
Okay, let me just take these two. And you're saying these two are being multiplied and those two are being multiplied, right? So why don't you multiply these two or multiply those two? Okay, it's because of the distributive property. In these two, it's a binomial, right? Is there a common factor to these two terms? And you'd be left with this plus that. So now I just combine it, get 7 times the square root of 7. That's why, because of that distributive property. And maybe that didn't answer it because I'm not sure if that fully answered your question, but ask me again if it's not clear as we go on. How many of you think you're how many think you're all right with this? Okay, it's really not that bad. Let me give you on page 729. Page 729, go ahead and do number 9. I gave you 30 seconds to do it. It takes you longer to write it than to actually work it out, hopefully. So number 9 on page 729. Whoa. Oh, you guys are done. Amazing. What's the answer, Harper?
13 times 6.
Okay, 13 times the square root of 6 is the answer. You guys good on that? Okay, what I did with the other class, I thought it was a great exercise. I want you guys to understand what your answers mean, and I want you to tell me what this number means as a decimal number. I want you to estimate for me. So this is what I'm going to do. Everyone is going to estimate. Point out your estimate as I walk by. I'm not going to make you call out. Go ahead. I'll give you a few moments. What's 13 times the square root of 6? Give me a good estimate. Try your best. Write a number down. Think about it a little bit. I won't rush you. Yeah, what's this right here worth? And you can round it to the nearest tenth. So try to be as accurate as you can to the nearest tenth. It goes on forever, but nearest tenth is good. I want to see your thoughts here.
So we can't get this.
Yeah, you should get a decimal to get as exact as you can. All right, I'll give you a few more moments and I'll come by and start looking at it. Please point it out as I come by. I'll come down this row, then up this row, then back down that row, then on the outside. So I'm going to zigzag through the class. Give me a number here, and I'll come back if you're not getting it. Okay, if you're working on it, it's great. Okay. All right, I'm seeing them. Okay.
Can I redo mine?
Yeah. All right. It's okay. All right. Okay. Oh yeah, I saw that one already. All right. Then. All right. Do I have a range in this class? I have a range from nothing all the way to, I think the highest one was like almost to the 3-digit numbers. Okay, I'm going to give you one piece of info that'll help you out, maybe a little bit more. The square root of 6, isn't that really close to the square root of 9 or the square root of 4? I mean, is it in between those two? Does anyone know what the square root of 4 is? Square root of 9? Okay, which is the square root of 6 closest to? Okay, square root of 4, which is 2. So this value is closer to 2 than it is 3. If it were right in the middle, wouldn't it be 2.5? But it's closer to 2, so what would you guys say is a 2.3? 2.3, all right. Use 2.3 for this value and give me another estimate. I'll give you a second chance. That's okay. If you got it, fine, good. If you didn't, I'm going to come by around. Ooh, sticking to the answer there. That's all right.
Oh, yeah.
Okay, I'm going to come back around. Oh, stick to the guns. My teacher in middle school history used to say, stick to your guns. And a lot of you guys are doing that.
You can see that.
I can. Kind of. Oh my. See a lot of numbers here. Oh. It's interesting. Some of you have the same number on there. Okay. How many of you, your first estimate, the one I asked you to do before I gave any help, is, pretty far off the one you did the second time? Pretty far off. Like, significantly. Like, I changed it. I'm glad you pointed something like that. Okay. How many of you, they were very close or the same? Very close or the same. Okay, good. That's showing good number sense. All right. Here's the official answer. Your batteries are low. That's not the answer. Okay. 13 square root of 6. Oh, the official answer, which I think I saw it on maybe 2 papers. Very close. And in the other class, very, very close. 30.
No.
1. Point. Yes, point. 8. 31.8.
31.2.
I got 31.8.
I got 32.
Oh, okay. Well, yes, you can use calculator. How many of you are you're between 29 and 33? 29 and 33. You're in between those two? How many of you are in between 30 and 32? 30, 32? Okay, how many of you got 31 point something? Oh. Is that a hand still? Okay. How many of you got 31 point, like you're maybe a few tenths away? What was your estimate?
31.2.
31.2?
Same.
Same. Tell me what you did, Ellie. How'd you figure that, 31.2? I want to know. Maybe it matches, maybe it's different. Go ahead.
Well, because I knew the square root was between 2 and 3, but closer to 2, but not that far from 9. Or like close to 4, but not that far from 9. I just did 2.4. 2.4, and then I multiplied that back to 13.
Okay, and so you guys use 2.4? So we said 2.3. 2.4 is a little bit closer, and they got, how many of you got 29.9? I saw that number a lot. Why'd you get 29.9?
2.3.
Because you used 2.3. Guys, you're very close, either one. And I saw the number on the first estimate for a few of you very close, which is impressive. The whole point of this is, you know what? This number, 13 times square root of 6, may not mean a lot, but it really all it means is about 30, right? Can you say about 30? That's the value of this expression. All right, I'll have you do that again in a little bit. You know what? Yeah, bless you. Let me give you another problem. Number 10. Same page, number 10. Make you stretch your minds a little bit. Don't say anything. Don't ask questions. Just go ahead and work it out. Number 10 on 729. 2 times the square root of 5 minus 5 times the square root of 2. Don't say anything. Some of you are confused. Some of you are mad. Some of you are, I don't care. Some of you are somewhere around there, maybe a mixture, which is kind of strange. But anyway, you're a mixture of all of them, or some of them, or none of them. And then I don't understand you at all. Give you a few moments to think about it. All right, Kyra. What's my answer? Or actually, you know what, Kyra, just read me the problem. Go ahead and read.
2 times the square root of 5 minus 5 times the square root of 2.
Yes.
Yes.
That was the answer.
Oh, sorry, God, that was the problem. Good job. Okay, can I combine these two terms right here? No. Okay, so what I write is this, guys. In simplest form. In simplest form. Sorry. Man, Mr. A's picky. Yep. Yeah, that's all right. In simplest form. That's your answer. Okay, have we ever had problems where they tell us to simplify and they're already simplified?
Yes.
That's okay. It happens. Now, please don't expect it to be a lot on your homework, although it can appear. Okay, let's go to example number 2. Let's extend our knowledge of dash 2 and today's lesson to example number 2. All right. 4 times the square root of 27 plus 5 times the square root of 12 plus 8 times the square root of... Oh, what?
What just happened?
Is that Brian's sign?
Oh no, we gotta prime factor this stuff.
Let's do it.
Oh, yeah.
Let's do it.
Yeah.
Okay.
Let's do it.
All right.
Let's do it.
If your square roots cannot be simplified anymore in simplest form, but I'm looking at these guys right here. Do you think I can factor them maybe? Okay. Let's take this one first. First term. 4 times the square root of, what's 27 prime factored?
3 times 3
times 3.
Yes, 3 times 3 times 3 times 3, that's 3. All right. 3 times 3 times 3. 3 to the third. There you go, yeah. What you're going to notice, guys, is a lot of times they give you the same numbers, and you're like, man, I got to do this one again. Well, hopefully you can start memorizing some just by doing them all. So 3 times square root of 3, 3 times 3 times 3 is what 27 breaks down to. This is a review of yesterday. Can this simplify?
Yes.
I have a pair of 3s. What comes out?
3.
A 3. What happens with the 4 and the 3? They get multiplied. They give me 12. And what was left behind? A 3. 12 times the square root of 3. Yay! Thank you for doing that, Mr. A. What's the point? All right, let's look at the second one. Maybe that'll help us.
Oh my goodness. Yes.
5 times the square root of 12. Can 12 be factored? Go. 2 times 2 times 3. And you've seen that. I think you've probably seen that. Maybe this is the third time you've seen it. You'll see it again. 2 can come out. What is this simplified here? 10 times the square root of 3. Positive 10 times the square root of 3. Okay, good. 8. 75 prime factor. Yes. No matter what you say, I would say yes.
Wait. It'll be 10.
Sometimes I want to... Okay. Sorry, I'm done. Edit, Swivl. Cut, Swivl. Action. All right. Here we have a common factor, 5. So what does this become? Positive 40 times the square root of 3. Oh! Oh!
Can we figure this one out?
Yeah, go ahead and figure it out. What do you get?
No, like the times 3.
Sorry, say that.
62.
Yeah, I'm hearing a lot. 62 times the square root of 3. That's your answer. Okay. Do you notice that when we first look at the problem, it either may look like it's in simplest form, there's nothing common, or wait, I think these can be simplified. Don't go rushing to simplest form because, yes, in this case, they actually are common. You just can't see it right away. I can't see it right away. 62 times the square root of 3. All right, I want an estimation. I'll give you a few. Oh, no, don't give it to me. I'm watching. I'm looking around. I want to see all of you. Do you have a question? Okay, thank you. Get your estimation on this right here. I want an estimate to the nearest tenth.
Oh, no, you gave us the answer.
No, I don't think I did.
No, I remember a couple of times ago, days ago, you told us the closest thing to it.
Gotcha. I see what you're saying. Okay. Do your best on this.
Oh, wait, I remember now.
I think I got a pretty good guess. What do you think?
And I'm going to come around and you're going to show me your estimate. And listen, guys, estimation is not just something you just, wow, I got the right, just by guessing. No, estimation is actually getting a guess based on information you have. I have info. I either know how to use that or not, and let's see how you do. And it takes practice to get better.
It'll work, and I have to correct it.
Great. What kind of calculator are you using?
My brain.
My brain.
Oh, good. Even better. All right, I'll come by. I'm just watching you guys work to see what your process is. This is a good skill because I don't get these numbers unless I put them into some context that I'm aware of, I'm familiar with. Okay? All right? And don't go bold. Put something down there. Write it down. Don't be afraid of your answer. I think someone got spot on. I'm wondering.
I'm bold with this one.
Okay, I'm just going to do one thing. I'm not going to talk much about it. Give you a little help. Possibly. I know who he is.
I have a question. So if you can take things out of the square rooting thing, can you factor the 62 into 2?
Like if you could divide it by, yeah. Let's say it was like 64, and you factor out a 4, and you put it in as 16 in there. It works. Yeah, you can go back and forth. Actually, there's one of you who got it pretty close that I've seen on that first run, who I don't suspect used the calculator.
I really did not.
I wasn't talking about you, but no.
Okay.
All right, I'm going to come by last time. Give me your estimate, your new or same. All right. Can I see it? Same? Stick to your guns on this. Okay, good. Sorry, where is it? Okay. Where is it? This? This?
I didn't use calculator.
Okay.
I promise.
What's the square root of 3?
Okay. Very impressive. And even if you didn't get exactly or very close to exactly, it's still pretty good on how you did.
Oh man.
Are you ready for this?
I'm ready.
All right, the answer, official answer, 107. 107.4.
Wait, can I say it first? No, 107.8.
There are two people who got very close to it. One person got it close the first time. And again,
I didn't use a calculator. I did not.
all right, Walker, what did you do then?
I used my book.
Oh, did someone write it?
Yeah.
Okay.
No,
Who got between 110 and 120? 110, excuse me, not 110, 120. 100 and 120. 100 to 120. Who got 100 to 120? Okay, just maybe a little bit below or above it. Who got between 105 to 115? 105 to 115. Okay, who got between 106 and 108? 106 and 108. Who got exact? Walker. Don't worry, Walker. I'll test you out. No, it's okay. Okay,
I got 108.5.
yeah, on the first time as I'm walking by, Vivian, what'd you get?
105.5.
Okay, I need Vivian to tell me what she did. So what did you do? How'd you figure that out?
Well, I guess it would be like around 1.5, but it was probably 1.5 or 1.5.
Uh-huh.
And I thought I need to go up a little bit, so I did.
Okay.
And then I multiplied that.
What was that up a little bit to?
1.7.
The square root of 3 is 1.73. So that gave you that, and then you did 1.7 times 1.7. Or sorry, you just did 1.7 times 62.
I did 1.7 times 1.7.
Yeah. Okay, guys, this needs to make more sense to us. We get practice. We'll get more practice. Josh, question? The right side, right. So the very right quarter of both eyes.
I can't see like.
Go. I don't want to find out the wrong way. Go.
Here, Josh, you can have some of it.
Good job, guys. Some of you were close. Even if you didn't get spot on, you're like a few off. That's not bad. It's an educated guess based on the information you know. Yes, ma'am?
What do you need to like multiply to get like the real?
Okay, you need to know what the square root of 3 is as best you can. 1.7 is very good. And then you do 1.7 times the 62. 1.7 times 62. That would get you very close to the answer. Okay, do number 14 on page 729. I hope we're not losing our focus because I have something I want to give to you guys and help you out, maybe some of you, but I can't do it until we're done. We're getting very close, so please stay with me. 14. Number 14 on page 729. Lisby, what do you think? Is that it? Should I make you guess what it's close to?
Yes.
Yes.
We won't do it on that. Someone give me a guess right away now.
I'm gonna go with like 8.42.
Okay? Last one.
7.56.
Okay, sorry, I'll get one more. Okay, those were actually all very close. 6.9. Who was the closest out of it? But it's close. Okay, yeah. The thing is, guys, all of us get better at this. I remember when I first got square roots and I really started doing this, I had this younger kid in my church, because we all went to the same like school basically, but he was a young kid. He'd say square root of 8, and I'd have to think 2.8, 2.83. And I would just try to guess what the answer is. And when I say square root of 8, let's see if it's still there. 2.8 2.83. Okay, now the thing is, it's not because I'm just like, wow, I'm not, some of your abilities are way better than mine or beyond mine, but it's just I have to think about it and like, I know what square root of 9 is, a little bit less than that, but not too far. Okay, boom, get your answer. Just practice, guys, you get better. And I want you guys to know what these are so that you can have more number sense, because it's funny, you ask a 11th grader what that means, no clue what it means. You don't know what that is? It's about 8, about 7, about 6. Okay, you guys get that. Because they know how to do the problem. Like you give them the problem, they'll laugh at you. And then you tell them what that means, and then the joke would be on them because they don't get it. They don't get it. And that's no good, guys. That's no good.
They don't want to get it, but they don't like know wrecked.
Wow, not wrecked. But no, it's sad, guys. I don't want you to be that. Wow, I got the answer. Wow, that's awesome work. Good answer. What does that mean? Can you come back another day and ask me? No. You need to tell me what it is that day.
It's your magic notebook.
Yes. Which magically got transferred onto this, and I'll show you how in just a moment.
Have you erased any notes?
No, not yet. I'm still on page, I think, 8.
How many pages?
32.
So you're going to get to 32 and then erase them all?
Erase them all. And it'll never end. Excuse me?
No, because I wanted to erase them.
I will. I want to get to it. It'll get to it soon.
Okay.
Okay, this problem is your last type of problem here. Oops. I have parentheses. Being multiplied by parentheses. Does anyone notice in the first set of parentheses, what kind of polynomial do I have? Binomial. Right here. And the second set, binomial. Does anyone remember how to multiply these out? Foil. Same thing, foil. Okay, I'm going to go through this slowly, guys, so that I'm not losing anyone. And this does review yesterday's lesson as well. Okay, first, 2 times the square root of 3 times the square root of 10. That's when I'm multiplying first. Okay, that's basically 2 times the 1 that's in front times the square root of, what's the square root of 3 times the square root of 10? Square root of 30. Okay, that's what I get when I multiply those two together. I multiply the numbers in front and multiply the square roots or the radicals. Excuse me, the radicands. It's technically the term. 2 times square root of 3 now times 4 times square root of 6, which is outer. All right, what's 2 times 4? Positive 8. What's the square root of 3 times the square root of 6? Square root of 18. That's how I got that second one. I'm calling for questions because I don't want to lose you here. Does anyone have a question on how I got these two values right here? So just take it one step at a time. Don't rush. All right, inside would be the opposite of the square root of 5, or negative square root of 5, times square root of 10 would be positive or negative? Negative. The square root of 50. Good. Square root of 50. Or the opposite of the square root of 50. And last, negative the square root of 5 times 4 times the square root of 6 would be negative 4 times the square root of 30. Oh, I got that first step done. Okay, a couple things I want you to do here. You're going to get products, and initially you might think, oh, cool, like terms, and you combine them, all done. But do you notice that, can I maybe simplify these, possibly? Okay, the square root of 30. I'm going to give you a hint. It's going to apply today. The square root of 30. Someone give me the prime factorization. 2 times 3 times 5, right? Does anything come out of that?
No, it doesn't.
So this is as simple as it gets. I'm going to combine these two together because they're as simple as they can get. What's 2 times the square root of 30 plus negative 4 times the square root of 30? Hello? Yes, I can. Bye. Ellie. That's your homework. Okay. Negative 2 times the square root of 30. But then I'm looking at those two terms in the middle. I'm thinking, they're not like terms. But can I simplify them? What's the square root of 18? It's prime. 2 times 3 times 3. I take that 3. What do I get with that one? So positive 24 times the square root of 2. I hope you guys see that. And I'm just rewriting that one. What about the square or the opposite of the square root of 50? That is not what I wanted. 2 times 5 times 5. You're going to see that one again. I hope you're at least getting it more down. 5 can come out, so I get minus 5 times the square root of 2. Oh! I need a final, ultimate, last answer. Yes. Katie. Not sure. Someone must be tickling her. I don't know. Okay. So, what happens with these two guys? Uh-huh. Yeah, what do you get? So I get negative 2 times the square root of 30 plus 19 times the square root of 2. Can these two combine? No, that's it. That's where you're left. So at first, it didn't seem like kind of, and look, this is what I do sometimes. I have someone look away from the problem, now look at the work in the problem. Oh my goodness, I don't get it. This is dumb. Guys, we took it one step at a time. One step at a time. Because when the 7th graders come in, on Tuesdays and Fridays, sometimes I leave it up. I want to get the reaction. And they come in. What's that? I'm like, I don't know. I don't even know what it is. Oh, let's look at it step by step. Okay, so don't worry. They're learning 8th grade math, yeah. You know what they're learning? What they just got tested over? Polynomials. Gross. Is that like a good gross or a bad gross? I don't know. I'm still interpreting language here with you guys. Wrecked. Is that good or bad? You got wrecked, man. Is that not how it works? Uh-oh. Your homework. Oh, that's where it is going to be 19 to 37 on.